Picture this. You're standing at a crossroads, facing a life-changing decision. Should you take that job across the country? Should you ask out your crush? Should you order pizza or Chinese food for dinner? Now, here's a question that might sound completely insane. What if I told you that in the moment you make that choice, the universe doesn't just continue down one path? What if every possible decision you could make actually happens, each in its own separate reality? What if right now, as you're watching this video, there are infinite versions of you living out every conceivable variation of your life? A version where you became a rock star, another where you never learned to ride a bike, one where dinosaurs never went extinct, and countless others where the smallest decisions rippled into completely different worlds. This isn't science fiction. This isn't some wild fantasy dreamed up by Hollywood writers. This is a serious scientific theory that emerged from one of the most famous thought experiments in physics history. A theory so mind-bending that it challenges everything we think we know about reality itself. Today, we're diving deep into the quantum rabbit hole to explore whether parallel worlds actually exist in every decision you make. We'll unpack the bizarre story of Schrödinger's cat, examine the shocking implications of quantum mechanics, and discover how a simple observation about atomic particles led scientists to propose that reality itself might be constantly splitting into infinite branches. But fair warning, what you're about to learn will change how you think about every choice you've ever made, because if this theory is correct, then every decision, no matter how small, creates entire universes. Every moment of indecision isn't just you weighing options. It's you standing at the epicenter of cosmic creation itself. And here's the most unsettling part. You'll never know which reality you end up in, because from your perspective, you only experience one timeline. The countless other versions of you, living completely different lives, remain forever invisible and unreachable. Before we dive deeper, make sure to like this video, subscribe, and drop a comment below with the reality you think you'd be living in. And stay with me until the very end, because the conclusion will shift how you see every choice you've ever made. So buckle up. We're about to explore one of the most profound questions in modern science. Do parallel worlds exist? And if they do, what does that mean for everything we think we know about choice, fate, and the nature of existence itself? Now, prepare yourselves, we begin. Let's start with a simple question that turned physics upside down. What happens when nobody's looking? In the early 1900s, scientists were discovering something deeply strange about the microscopic world. Particles, they found, don't behave like the objects we're familiar with in our everyday lives. When you're not observing them, they seem to exist in multiple states simultaneously. An electron, for instance, doesn't just orbit an atom in one specific path. Instead, it exists in what physicists call a superposition, occupying all possible orbits at the same time. This sounds ridiculous, right? How can something be in multiple places at once? How can a particle spin clockwise and counterclockwise simultaneously? Yet experiment after experiment confirmed this bizarre behavior. The quantum world operates by rules so alien to our everyday experience that even the scientists studying it found them hard to accept. But here's where things get really weird. The moment you try to measure or observe that particle, something called wave function collapse occurs. Suddenly, the particle snaps into a single definite state. It's as if the universe makes up its mind only when someone bothers to look. This observation troubled many physicists, but none more so than Austrian physicist Erwin Schrödinger. In 1935, he devised a thought experiment that would become one of the most famous paradoxes in science. He wanted to show how absurd quantum mechanics would be if applied to everyday objects. Imagine, Schrödinger said, a sealed box containing a cat. Inside this box is a diabolical device. A Geiger counter monitors a radioactive atom that has exactly a 50% chance of decaying within an hour. If the atom decays, the Geiger counter detects it and triggers a mechanism that breaks a flask of poison, killing the cat. If the atom doesn't decay, the cat lives. According to quantum mechanics, before anyone opens the box to check, the radioactive atom exists in superposition. It has both decayed and not decayed simultaneously. And if we follow quantum logic to its conclusion, this means the cat must also be in superposition. The cat is both alive and dead at the same time. Only when someone opens the box and observes the cat does the wave function collapse, forcing the universe to choose whether the cat is alive or dead. Until that moment of observation, the cat exists in this impossible state of being simultaneously alive and dead. Schrödinger thought this would demonstrate how ridiculous quantum mechanics was when applied to macroscopic objects. Surely, he reasoned, cats can't be both alive and dead. There must be something wrong with our understanding of quantum physics. But instead of discrediting quantum mechanics, Schrödinger's cat opened up an even more mind-bending possibility. What if the cat isn't both alive and dead in one reality? What if, instead, reality itself splits? This is where the many worlds interpretation enters the picture, and it changes everything. In 1957, physicist Hugh Everett proposed a radical solution to the measurement problem in quantum mechanics. Instead of wave functions collapsing when observed, Everett suggested that all possible outcomes actually occur. Each possibility branches off into its own separate universe. According to this interpretation, when the radioactive atom in Schrödinger's box reaches that critical moment, the universe doesn't collapse into one outcome. Instead, it splits. In one branch of reality, the atom decays, the poison is released, and the cat dies. In another branch, the atom doesn't decay, and the cat lives. Both realities are equally real, equally valid, and equally complete universes. The person opening the box doesn't cause one outcome or the other, they simply discover which branch of reality they happen to be in. Meanwhile, another version of them in a parallel universe is making the opposite discovery. This means every quantum event, every moment of uncertainty at the atomic level creates new universes. And since quantum events are happening constantly, everywhere, at every moment, new realities are being born at an incomprehensible rate. But quantum events aren't the only source of universal branching. Every decision you make, every choice you face, might also create new worlds. Think about it this way. Your brain is a biological computer made up of neurons firing in complex patterns. These neurons operate through electrochemical processes that, at their fundamental level, involve quantum mechanics. When you face a decision, quantum uncertainty in your brain might lead to different outcomes in different universes. In one universe, you decide to study physics and become a scientist. In another, you choose art and become a painter. In yet another, you never make the choice at all because a completely different chain of events led you down an entirely different path. Every morning when you wake up and decide what to wear, new universes branch off. Universe A, where you wear the blue shirt. Universe B, where you choose the red one. Universe C, where you decide to stay in bed an extra 10 minutes and miss your usual train, leading to a completely different day. The implications are staggering. If the many worlds interpretation is correct, then there are versions of you experiencing every possible variation of your life right now. There's a universe where you made different choices in high school and ended up in a completely different career. There's a reality where you never met your best friend, and another where you married your childhood crush. There are universes where historical events unfolded differently because of different quantum outcomes. A reality where the asteroid that killed the dinosaurs missed Earth entirely. A world where a different sperm reached the egg when your parents conceived you, creating a sibling instead. Universes where World War II never happened, where the internet was never invented, where humans never evolved at all. But here's what makes this theory both beautiful and terrifying. You can never access these other realities. You can never know what choices the other versions of you made. From your perspective, you experience only one timeline, one sequence of events, one life. The infinite other possibilities remain forever beyond your reach. This creates a profound philosophical question. If all possibilities exist across infinite universes, do your choices actually matter? If there's a universe where you make every possible decision, does free will have any meaning? Some philosophers argue that this makes every choice infinitely important because each decision creates entire worlds filled with conscious beings living out their lives. Others suggest it makes nothing matter since every outcome happens somewhere regardless of what you choose. But perhaps the most unsettling aspect of the many worlds theory is what it implies about the nature of death itself. In some interpretations, consciousness might always continue in the branches where you survive, meaning that from your subjective experience, you might be effectively immortal. Every near miss, every close call, every moment where you almost died would be a branching point where other versions of you weren't so lucky. The evidence for parallel worlds isn't direct. We can't point a telescope at another universe or travel between realities, but the mathematical foundations of quantum mechanics strongly support the possibility. The equations that govern quantum behavior naturally lead to the many worlds interpretation without requiring any additional assumptions about wave function collapse. Moreover, recent experiments in quantum physics have demonstrated phenomena that seem to support the existence of multiple realities. Quantum computers, for instance, appear to perform calculations by accessing computational resources that shouldn't exist in a single universe. Some physicists interpret this as evidence that quantum computers are borrowing processing power from parallel versions of themselves. Scientists have also observed quantum interference patterns that suggest particles are interacting with invisible versions of themselves from other realities. These shadow particles, as they're sometimes called, leave subtle but measurable effects that hint at the presence of parallel worlds. The many worlds interpretation also provides elegant solutions to several puzzles in quantum mechanics. It explains why quantum measurements appear random from our perspective while maintaining the deterministic nature of the underlying physical laws. It resolves the paradox of Schrödinger's cat without requiring mysterious wave function collapse. And it offers a framework for understanding the apparent fine-tuning of physical constants in our universe. If infinite universes exist with different physical laws and constants, then it's not surprising that we find ourselves in one where conditions are just right for life. We couldn't exist in the universes where physics doesn't allow for complex chemistry or stable atoms. This is known as the anthropic principle, and it gains new meaning in a multiverse context. But the theory raises as many questions as it answers. How do we define the boundaries between different universes? What determines which measurements or decisions cause branching? And perhaps most importantly, if we can never interact with other realities, can we ever truly prove they exist? These questions push us to the very limits of what science can tell us about reality. They force us to grapple with the fundamental nature of existence itself and question assumptions we've held since childhood about the uniqueness and singularity of our experience. As we continue exploring this mind-bending theory, we'll discover how modern experiments are testing the boundaries between quantum and classical worlds. We'll examine the role consciousness might play in creating reality and investigate whether there might be ways to detect or even communicate with parallel universes. We'll also delve into the implications for artificial intelligence, time travel, and the ultimate fate of the multiverse itself. Because if parallel worlds do exist, then understanding them isn't just an abstract philosophical exercise. It might be the key to unlocking technologies and possibilities that seem like magic from our current perspective. The rabbit hole goes deeper than you might imagine, and we've only just begun to fall. The deeper we venture into the quantum realm, the more we realize that our everyday intuitions about reality might be completely wrong. But before we explore the cutting-edge experiments that might prove parallel worlds exist, we need to understand how we got from Schrödinger's simple thought experiment to a theory that suggests infinite versions of you are living infinite lives right now. The journey begins with a fundamental question that has puzzled physicists for over a century. Why does the quantum world behave so differently from the world we experience every day? When you throw a baseball, it follows a predictable path. You can calculate exactly where it will land based on the angle, speed, and forces acting upon it. But when scientists tried to apply the same logic to electrons and photons, they discovered something that defied all common sense. Particles at the quantum level don't just take one path from point A to point B. They take every possible path simultaneously. This isn't a limitation of our measurement tools or a gap in our understanding. It's a fundamental feature of reality itself, and the implications of this discovery would eventually lead us to question whether reality itself might be branching and multiplying with every passing moment. The first hints of this bizarre behavior emerged from the famous double-slit experiment. Scientists fired individual photons through two parallel slits toward a detection screen. Logic suggests each photon should go through one slit or the other, creating two distinct patterns on the screen. Instead, they found something impossible. The photons created an interference pattern, as if each individual particle had somehow travelled through both slits at the same time and interfered with itself. This wasn't just strange, it was reality-shattering. How can a single particle be in two places at once? How can it interfere with itself? The mathematics worked perfectly, but the physical interpretation challenged everything we thought we knew about the nature of existence. Even more perplexing was what happened when scientists tried to observe which slit each photon actually travelled through. The moment they set up detectors to watch the particles, the interference pattern disappeared. The photons began behaving like normal particles again, going through one slit or the other, never both. It was as if the universe knew it was being watched and changed its behavior accordingly. This observer effect became one of the most mysterious aspects of quantum mechanics. Why should conscious observation change the behavior of fundamental particles? What makes a measurement special? And most importantly, where exactly does the quantum world end and the classical world begin? These questions tormented physicists for decades. The prevailing interpretation, developed by Niels Bohr and Werner Heisenberg, suggested that particles exist in superposition until measured, at which point their wave function collapses into a definite state. This Copenhagen interpretation worked mathematically, but it left profound philosophical questions unanswered. What constitutes a measurement? Does consciousness play a special role in collapsing wave functions? And why does the universe seem to make random choices when forced to pick a definite outcome from multiple possibilities? Hugh Everett found these questions unsatisfying. As a graduate student at Princeton in the 1950s, he proposed a radically different interpretation. What if wave functions never collapse? What if every possible outcome of every quantum measurement actually occurs, but in separate, non-communicating branches of reality? This many worlds interpretation eliminated the need for mysterious wave function collapse. Instead of the universe randomly selecting one outcome from many possibilities, all possibilities manifest in parallel realities. The apparent randomness we observe is simply a consequence of not knowing which branch of the multiverse we happen to inhabit. Everett's idea was initially dismissed by the physics establishment. It seemed to violate Occam's razor by multiplying entities beyond necessity. If we can't observe these other worlds, why assume they exist? The Copenhagen interpretation might be philosophically unsatisfying, but at least it didn't require belief in infinite invisible universes. But as quantum mechanics matured and new experiments revealed even stranger phenomena, Everett's interpretation began to gain credibility. The mathematics of quantum mechanics naturally leads to the many worlds conclusion without requiring additional assumptions about collapse mechanisms or the special role of consciousness. Consider what happens during quantum measurement from the many worlds perspective. When a scientist measures the spin of an electron, the universe splits into two branches. In one branch, the electron spins up and the scientist observes spin up. In the other branch, the electron spins down and the scientist observes spin down. Both outcomes are equally real, but the two versions of the scientist can never communicate with each other. This process of universal branching occurs not just during deliberate scientific measurements, but constantly, everywhere, at every moment. Every quantum interaction in every atom, in every object throughout the universe creates new branching points. The rate of universe creation is incomprehensibly vast, with new realities being born trillions upon trillions of times per second. But quantum branching might not be the only source of parallel worlds. Some interpretations suggest that macroscopic events, including human decisions, can also cause universal splitting. This possibility emerges from the recognition that human brains are ultimately quantum mechanical systems. Your neurons operate through electrochemical processes that depend on the movement of ions and electrons across cell membranes. These processes involve quantum tunneling effects, where particles pass through energy barriers they classically shouldn't be able to cross. The timing of neural firing patterns might be influenced by quantum uncertainty, making your thoughts and decisions genuinely unpredictable, even in principle. When you face a choice between chocolate and vanilla ice cream, quantum fluctuations in your brain might tip the decision one way or another in different universal branches. The version of you that chooses chocolate experiences a slightly different timeline than the version that chooses vanilla. These small differences compound over time, eventually leading to dramatically different life experiences. This raises profound questions about personal identity and the nature of the self. If there are countless versions of you making different choices in parallel universes, which one is the real you? Are they all equally valid? Do they share the same consciousness, or are they completely separate individuals who happen to share the same history up to the point of branching? Some philosophers argue that personal identity extends across all branches of the multiverse. In this view, you are not just the single conscious experience you're aware of right now, but the sum total of all your parallel selves across infinite realities. Your complete identity includes the version of you that became a doctor, the one that moved to Japan, and the countless others living out every conceivable variation of your life. Others maintain that consciousness is necessarily singular and bounded. Each branch contains a separate individual with their own unique stream of experience. These parallel selves might share your memories up to the point of branching, but they are fundamentally different people living different lives in different worlds. The implications extend far beyond personal identity. If parallel worlds exist, they might contain the answers to some of history's greatest what-if questions. There could be universes where the Library of Alexandria never burned, where the Roman Empire never fell, where the Renaissance began centuries earlier. Every historical turning point might represent a branching of realities, with different outcomes playing out in parallel timelines. Scientific discoveries might unfold differently across the multiverse. Perhaps there are universes where Einstein never developed relativity, where Darwin never conceived of evolution, where the double helix structure of DNA remains undiscovered. Conversely, there might be realities where science has advanced far beyond our current understanding, where diseases we consider incurable have been eliminated, where technologies we can barely imagine are commonplace. The existence of parallel worlds also raises intriguing possibilities for understanding the apparent fine-tuning of our universe. The physical constants that govern our reality seem precisely calibrated to allow for the existence of stars, planets, and life. Even tiny changes to the strength of fundamental forces or the masses of elementary particles would result in a universe incapable of supporting complexity. In a single universe, this fine-tuning might seem to require explanation. Why are the constants just right for life? But in a multiverse containing every possible combination of physical laws and constants, our existence becomes unremarkable. We find ourselves in a life-supporting universe not because it was designed for us, but because we couldn't exist in the universes where the constants are different. This anthropic reasoning provides a naturalistic explanation for apparent cosmic design without invoking supernatural intervention. We observe a fine-tuned universe for the same reason fish observe water-filled environments. It's not that the ocean was created for fish, but that fish can only exist where there's water to support them. But the many worlds interpretation faces significant challenges and criticisms. The most obvious objection is its apparent violation of Occam's razor. Why postulate infinite invisible universes when simpler explanations might suffice? The theory seems to multiply entities beyond any reasonable necessity. Proponents argue that many worlds is actually the simplest interpretation of quantum mechanics. It requires no additional postulates beyond the basic mathematical framework. Wave function collapse, by contrast, requires assuming that something special happens during measurement that somehow selects one outcome from many possibilities. Another criticism concerns the theory's lack of testability. If we can never observe or interact with parallel worlds, how can we ever verify their existence? Science depends on making predictions that can be confirmed or refuted through experiment. A theory that postulates unobservable entities might be mathematically elegant, but it could be considered scientifically meaningless. However, some physicists argue that the many worlds interpretation does make testable predictions. It suggests that quantum mechanics should remain valid at all scales without any threshold where classical behavior emerges. It also predicts that quantum computers should be able to perform certain calculations that would be impossible in a single universe, potentially accessing computational resources from parallel realities. Recent experiments have begun probing the boundaries between quantum and classical behavior with unprecedented precision. Scientists have demonstrated quantum superposition in increasingly large and complex systems, from individual atoms to molecules containing hundreds of atoms. They've created quantum entanglement between particles separated by vast distances and maintained coherent superposition states for longer and longer periods. These advances bring us closer to testing whether the quantum-to-classical transition involves genuine wave function collapse or simply the practical impossibility of maintaining coherence in complex systems. If large-scale objects can be shown to exist in genuine superposition states, it would provide strong evidence for the many worlds interpretation. The development of quantum computers represents another potential avenue for testing multiverse theories. These devices rely on quantum superposition and entanglement to perform calculations that would be impossible with classical computers. Some interpretations suggest that quantum computers derive their power from accessing computational resources distributed across parallel universes. If this interpretation is correct, then quantum computers might provide indirect evidence for the existence of parallel worlds. The fact that certain quantum algorithms can solve problems exponentially faster than any known classical algorithm hints that quantum computers might indeed be tapping into resources beyond our single reality. As our understanding of quantum mechanics deepens and our experimental capabilities expand, we edge closer to resolving these fundamental questions about the nature of reality. The answers we discover might revolutionize not just physics, but our entire understanding of existence, consciousness, and our place in the cosmic order. The journey into parallel worlds has only just begun, and the destination remains shrouded in mystery. But with each new discovery, each refined experiment, and each theoretical breakthrough, we move closer to understanding whether the universe we experience is all there is, or merely one thread in an infinite tapestry of parallel realities. The implications of parallel worlds extend into realms that would have seemed like pure fantasy just decades ago. But as we push deeper into this quantum rabbit hole, we encounter possibilities that challenge not just our understanding of physics, but the very foundations of what it means to be human in an infinite multiverse. Consider the nature of probability itself. In our everyday experience, we think of probability as a measure of uncertainty. When you flip a coin, there's a 50% chance it will land heads. But in the many worlds interpretation, that coin doesn't randomly choose heads or tails. Instead, the universe splits into two branches. In one, the coin shows heads. In the other, it shows tails. Both outcomes are equally real and equally certain within their respective realities. This transforms probability from a measure of uncertainty into a measure of how reality branches. When we say there's a 30% chance of rain tomorrow, we're not expressing uncertainty about a single future. We're describing the proportion of parallel universes in which rain occurs. 70% of tomorrow's realities will be dry, while 30% will be wet. This probabilistic branching occurs at every level of reality, from the quantum fluctuations in atomic nuclei to the firing patterns in your brain as you process these very words. Each quantum interaction creates a branching point where multiple outcomes spawn multiple universes. The mathematics suggests that the rate of this branching is so astronomical that new realities are being born faster than any number we could meaningfully comprehend. But here's where things get truly mind-bending. If new universes are constantly being created, what happens to the old ones? Do they persist forever, accumulating like layers of sediment in some cosmic archaeological record? Or do some branches somehow merge back together, reducing the infinite multiplication of realities? Most interpretations of the many worlds theory suggest that once universes branch apart, they remain forever separated. The branch where you chose coffee this morning can never reconnect with the branch where you chose tea. These parallel timelines diverge like tributaries flowing away from a river, never to meet again. This permanent separation creates what physicists call decoherence. As universes branch and diverge, they lose the ability to interfere with each other quantum mechanically. The coffee universe and the tea universe become causally disconnected, unable to influence each other's evolution. From the perspective of any single branch, the others might as well not exist. Yet some theoretical physicists have proposed more exotic possibilities. Perhaps under certain extreme conditions, parallel universes might briefly reconnect or influence each other. These interactions could manifest as subtle anomalies in our physical laws or unexplained phenomena that seem to violate conservation of energy or information. Some researchers have even speculated about technological methods for detecting or communicating with parallel worlds. If universes can influence each other through quantum mechanical effects, it might be possible to engineer systems that amplify these interactions. Imagine devices that could send messages across the multiverse or sensors that could detect the presence of nearby parallel realities. The search for such interdimensional communication faces enormous theoretical and practical challenges. The decoherence that separates parallel worlds appears to be fundamental and unavoidable in most circumstances. Any system complex enough to encode and transmit meaningful information would likely decohere too quickly to maintain connections across universe boundaries. But quantum mechanics has surprised us before. Phenomena that seemed impossible from a classical perspective, like quantum tunneling and entanglement, turned out to be not just real, but technologically useful. Perhaps the barriers between parallel worlds are not as absolute as they appear. The possibility of parallel world communication raises profound ethical questions. If we could somehow contact alternate versions of ourselves, would we have obligations to them? Could we learn from their experiences or share knowledge across dimensional boundaries? Would communication between parallel selves constitute a form of time travel, allowing us to receive information about the consequences of different choices? These questions become even more complex when we consider the nature of consciousness across the multiverse. If every possible version of you exists in parallel realities, which conscious experience is authentically yours? Do all versions share some deeper connection? Or are they completely independent minds that happen to share a common origin? Some interpretations suggest that consciousness itself might play a special role in the branching of realities. Perhaps the act of making a conscious decision creates universe splits in ways that purely physical quantum events do not. This would make human choices fundamentally different from random quantum fluctuations, imbuing our decisions with cosmic significance. In this view, every moment of conscious choice becomes an act of universe creation. When you decide to smile at a stranger on the street, you're not just affecting your local timeline. You're spawning entire realities where that interaction leads to friendship, romance, career opportunities, or chains of kindness that ripple across generations. The stranger who receives your smile branches into versions that have better days, different moods, altered life trajectories. The mathematical framework of quantum mechanics provides tools for calculating the probability distributions of these branches, but it cannot tell us which branch any particular consciousness will experience. From your subjective perspective, you always find yourself in exactly one timeline, unable to access the memories or experiences of your parallel selves. This creates a peculiar form of loneliness. If infinite versions of you exist across the multiverse, living every conceivable variation of your life, you remain forever isolated within your single thread of experience. You cannot know what paths the other versions chose, or what wisdom they might have gained from different decisions. Yet this isolation might also be a source of meaning and responsibility. If your choices create entire universes filled with conscious beings living out their lives, then every decision carries profound weight. The version of reality you help create through your actions becomes home to countless minds that will never exist in other branches. This perspective transforms ethics from a matter of consequences within a single timeline to a question of what kinds of universes we choose to create. Should we make decisions that spawn realities filled with suffering, or should we strive to create branches where happiness and fulfillment are more likely? Do we have obligations to the conscious beings who will inhabit the futures we help bring into existence? The many worlds interpretation also offers a unique perspective on death and mortality. In a single universe, death represents the absolute end of conscious experience, but in an infinite multiverse, death becomes more complex and ambiguous. Consider what happens when you face a life-threatening situation. In the many worlds view, the universe branches into outcomes where you survive and others where you don't. The versions of you that survive continue experiencing consciousness in their respective branches. The versions that don't survive simply cease to exist in those timelines. From the perspective of surviving versions, it might appear that you always narrowly escape death through unlikely coincidences or last-minute interventions. Each near-death experience represents a branching point where some versions of you weren't so fortunate, but the surviving consciousness only experiences the branches where life continues. This quantum immortality hypothesis suggests that consciousness might persist indefinitely by always finding itself in the branches where survival occurs, no matter how improbable those branches become. The conscious experience would continue in increasingly unlikely scenarios, surviving accidents, diseases, and aging through ever more remarkable circumstances. But quantum immortality raises disturbing questions about the quality of survival. If consciousness persists only in the most improbable branches, those realities might involve extreme suffering or degradation. Living forever might not be a gift if the only way to continue existing is through barely functional survival in the most unlikely corners of the multiverse. Moreover, the hypothesis assumes that consciousness somehow naturally gravitates towards survival branches rather than being equally distributed across all possibilities. This assumption lacks clear theoretical justification and might reflect wishful thinking rather than genuine physics. The many worlds interpretation also provides a framework for understanding some of the deepest puzzles in cosmology and fundamental physics. Why do we observe the particular physical constants and laws that govern our universe? Why does reality seem fine-tuned for the existence of complexity and life? In a single universe, these questions might require invoking design or extraordinary coincidence. But in an infinite multiverse containing every possible combination of physical laws, our observations become unremarkable. We find ourselves in a universe with life-supporting physics, not because it was specially created for us, but because we could not exist to make observations in universes with different laws. This anthropic reasoning extends beyond the basic constants of physics to more subtle features of our reality. The particular history of cosmic evolution that led to our solar system, our planet, and ultimately to conscious observers like ourselves might seem incredibly unlikely from a single universe perspective. But in an infinite multiverse, even the most improbable sequences of events occur in some branches. The many worlds interpretation thus provides a naturalistic explanation for apparent cosmic fine-tuning without requiring supernatural intervention or intelligent design. The universe appears perfectly suited for our existence because we are observing it from within one of the branches where such suitability actually occurred. This anthropic logic has implications for our understanding of life and intelligence elsewhere in the universe. If we exist in a multiverse where every possible configuration of matter and energy plays out across infinite realities, then life and intelligence must arise in countless forms across countless worlds. There would be branches where life evolved very differently on Earth, where intelligence emerged in species we can barely imagine, where civilization developed along completely alien trajectories. There would be realities where humans never evolved, where dinosaurs developed technology, where conscious machines arose before biological life. The vastness of the multiverse ensures that every possible form of consciousness and intelligence that could exist actually does exist somewhere. We are not unique or special in any cosmic sense, but rather one manifestation of the universe's tendency to generate complexity and awareness wherever conditions allow. This perspective is both humbling and inspiring. It suggests that consciousness and intelligence are fundamental features of reality, not rare accidents confined to our single planet. Yet it also emphasizes the preciousness of our particular thread of experience within the vast tapestry of possible realities. As we continue to develop our understanding of quantum mechanics and explore its implications for the nature of reality, we edge closer to definitive answers about the existence of parallel worlds. The next generation of experiments and theoretical developments may finally resolve whether we inhabit a single, unique universe or one thread in an infinite multiverse of possibilities. The stakes of this question could not be higher. If parallel worlds exist, they fundamentally change what it means to be human, what it means to make choices, and what it means to exist as a conscious observer in a reality far stranger and more magnificent than our ancestors ever imagined. The journey into the quantum realm has revealed that reality is far more mysterious than it appears on the surface. What seems like a solid, predictable world governed by clear cause and effect relationships dissolves into probability clouds and parallel possibilities when examined at its most fundamental level. We stand at the threshold of discoveries that may revolutionize our understanding of existence itself. The cat in Schrödinger's box may not be the only thing existing in multiple states simultaneously. We all might be quantum cats, living and dying, choosing and not choosing, succeeding and failing across infinite parallel realities we can never directly perceive, but which may be as real as the world we experience every day. But what if we could peek behind the curtain? What if there were ways to detect the shadows cast by parallel worlds, even if we can't visit them directly? This isn't just philosophical speculation anymore. Scientists around the world are designing experiments that could provide evidence for the existence of parallel realities. These aren't science fiction fantasies, but serious research programs funded by major universities and government agencies. The key lies in understanding that while parallel worlds might be causally disconnected from our reality, they could still leave subtle fingerprints on our universe. Think of it like hearing a conversation through a thick wall. You can't make out the words, but you know something is happening on the other side. One of the most promising approaches involves studying quantum interference patterns in unprecedented detail. Remember the double-slit experiment. When particles interfere with themselves, they might actually be interfering with versions of themselves from parallel worlds. If scientists can measure these interference patterns with extreme precision, they might detect tiny deviations that could only be explained by the presence of nearby parallel realities. Researchers at Oxford University have proposed experiments using increasingly large molecules to test the boundaries of quantum superposition. If they can demonstrate that complex biological molecules can exist in superposition states, it would provide strong evidence that the quantum behavior we see in simple particles extends all the way up to the macroscopic world. But perhaps the most intriguing experiments involve testing the limits of quantum computing itself. These machines appear to solve certain problems by accessing computational resources that shouldn't exist in a single universe. When a quantum computer factors a large number using Shor's algorithm, it seems to try every possible solution simultaneously. But where do all these parallel calculations actually happen? If the many worlds interpretation is correct, the quantum computer is literally borrowing processing power from versions of itself in parallel universes. Each branch of reality contributes a small piece to the overall calculation, allowing the machine to solve problems that would take classical computers longer than the age of the universe. This suggests a remarkable possibility. Quantum computers might be our first technology that actually operates across multiple realities. A quantum algorithm, your potentialities. Every time you run coordinating with infinite versions of yourself in parallel worlds to solve a problem that none of you could tackle alone. Scientists are now designing quantum computers specifically to test this multiverse hypothesis. If they can create algorithms that require more computational resources than should be available in a single universe, it would provide compelling evidence for parallel worlds. But the implications go far beyond just proving a theoretical point. If we can harness computational power from parallel realities, we might be able to solve problems that are fundamentally impossible in our universe alone. Climate modeling, drug drug discovery, artificial intelligence, cryptography. Every field that depends on complex calculations could be revolutionized by accessing the infinite computational resources of the multiverse. Some researchers are even exploring whether quantum computers could be used for limited communication with parallel worlds. By carefully designing quantum states that encode information, it might be possible to send simple messages to nearby realities and receive responses back. The challenges are enormous. Any information transfer between worlds would have to occur through quantum mechanical channels that are incredibly fragile and easily disrupted. The slightest environmental interference would destroy the delicate quantum states needed for interdimensional communication. Yet the potential rewards are beyond imagination. Contact with parallel worlds could provide access to scientific knowledge developed by alternate versions of humanity. Imagine learning about cures for diseases from realities where medical research followed different paths, or discovering new technologies from worlds where different physical theories were pursued. But such communication would also raise profound ethical dilemmas. Would we have the right to interfere with the development of parallel civilizations? Could knowledge transfer between worlds create paradoxes or unintended consequences? Would contact with advanced parallel societies be beneficial or potentially catastrophic for our own development? These questions become even more complex when we consider the possibility that some parallel worlds might be far ahead of us technologically. If infinite realities exist, there must be versions of human civilization that are centuries or millennia more advanced than our own. These advanced societies might already possess the technology to communicate across the multiverse. This raises an unsettling possibility. Maybe we're not trying to make first contact with parallel worlds. Maybe parallel worlds have already made contact with us and we simply haven't recognized the signs. Consider the strange coincidences and unexplained phenomena that pepper human history. Events that seem impossibly unlikely, discoveries that appear to come out of nowhere, moments when the course of history pivots on what seems like pure chance. What if some of these aren't coincidences at all, but subtle interventions from parallel versions of ourselves? The mathematics of probability in a multiverse context suggests that even the most unlikely events should occur regularly across infinite realities. But perhaps some events are so improbable that they can only happen with assistance from other worlds. Maybe breakthrough scientific discoveries, artistic inspirations, and moments of crucial historical importance sometimes receive guidance from parallel civilizations that have already walked similar paths. This isn't suggesting direct intervention in the sense of science fiction stories. The laws of physics appear to prevent crude manipulation across world boundaries, but quantum mechanical effects might allow for subtle influences that nudge probability distributions in favorable directions without violating causality or conservation laws. Think about the moment when inspiration strikes, when a scientist suddenly sees the solution to a problem they've struggled with for years, or when an artist conceives a masterpiece that seems to come from nowhere. These moments feel different from ordinary thinking. They arrive with a sense of inevitability, as if the idea already existed somewhere and simply needed to be discovered. What if that somewhere is literally another world? What if moments of inspiration represent brief quantum connections to parallel selves who have already made these discoveries? The knowledge doesn't transfer directly, but the quantum correlation between parallel minds might create conditions where similar insights arise naturally. This would explain why multiple scientists often make the same discoveries independently around the same time. Why artistic movements seem to emerge simultaneously in different places. Why technological breakthroughs often occur in clusters, as if the ideas are somehow present in the collective consciousness waiting to be uncovered. The concept of morphic resonance proposed by biologist Rupert Sheldrake suggests that once a pattern of organization appears somewhere, it becomes easier for similar patterns to emerge elsewhere. While Sheldrake's ideas remain controversial within mainstream science, they take on new meaning in the context of parallel worlds. If infinite versions of reality exist, then every possible pattern of organization has already emerged somewhere in the multiverse. The quantum connections between parallel worlds might allow these patterns to influence the development of similar structures in nearby realities. Learning becomes easier once someone somewhere has already learned. Innovation accelerates when the innovations already exist in parallel timelines. This multiverse memory effect could explain some of the puzzling aspects of human cultural and technological development. Why do certain ideas seem to be in the air during particular historical periods? Why do breakthrough technologies often emerge simultaneously from multiple independent research groups? Perhaps human civilization doesn't develop in isolation within a single timeline. Maybe our progress is subtly guided by quantum correlations with more advanced versions of ourselves existing in parallel realities. We're not copying their achievements directly, but we're influenced by the patterns they've already established. This suggests that our potential for advancement might be far greater than we realize. If we can learn to recognize and amplify these quantum connections to parallel worlds, we might be able to accelerate our own development by drawing upon the accumulated knowledge of infinite alternate civilizations. The implications for education, research, and creativity are staggering. Instead of starting from scratch with every new generation, we might be able to tap into the collective wisdom of the multiverse. Problems that seem intractable in our reality might already be solved in others. Technologies that appear impossible might already be commonplace in more advanced parallel worlds. But harnessing these connections would require developing entirely new approaches to consciousness and cognition. We'd need to understand how the quantum processes in our brains interface with parallel versions of ourselves. We'd need techniques for amplifying the subtle signals that might be arriving from other realities while filtering out the quantum noise that would inevitably accompany them. Some researchers are already exploring these possibilities through meditation practices, altered states of consciousness, and advanced neurofeedback techniques. If parallel worlds influence our reality through quantum mechanical channels in the brain, then methods that enhance quantum coherence in neural networks might increase our sensitivity to interdimensional communication. This opens up fascinating possibilities for human enhancement and expanded consciousness. Instead of being limited to the knowledge and experiences of a single lifetime, we might learn to access the wisdom accumulated across infinite parallel lives. Every skill you never developed, every language you never learned, every experience you never had might exist within reach if we can establish stronger connections to our parallel selves. But this also raises profound questions about personal identity and individual achievement. If your insights and discoveries are influenced by parallel versions of yourself, how much credit can you claim for your own accomplishments? Are you an individual consciousness making independent choices? Or are you part of a vast multiversal mind that spans infinite realities? These questions challenge our most basic assumptions about selfhood and free will. If every decision you make is influenced by quantum correlations with parallel selves who have already made similar choices, then the boundaries between different versions of yourself become increasingly blurred. Perhaps individual consciousness is an illusion created by our limited perspective within a single timeline. Maybe the real you is the sum total of all parallel selves across infinite worlds, experiencing every possible variation of your life simultaneously. What you think of as your unique personal history might just be one thread in a vast tapestry of parallel experiences. This multiversal perspective on consciousness could revolutionize our understanding of death, memory, and personal growth. If your consciousness extends across infinite parallel realities, then the death of your body in this timeline doesn't necessarily mean the end of your existence. Other versions of you continue living in countless parallel worlds, carrying forward the patterns of thought and memory that define your identity. Similarly, the memories and skills you've developed in this lifetime might not be lost when you die. They become part of the quantum field that connects all parallel versions of yourself, potentially accessible to other iterations of your consciousness in different realities. This suggests a form of technological immortality that doesn't require uploading minds to computers or extending biological life indefinitely. Instead, consciousness itself might be naturally immortal, persisting across the infinite branching structure of parallel worlds. Death becomes not an ending, but a transition from experiencing one timeline to experiencing others. But if consciousness naturally persists across multiple realities, why don't we remember our parallel lives? Why does each version of yourself seem isolated within its own timeline, unaware of the experiences happening in other worlds? The answer might lie in the nature of quantum decoherence. Just as quantum superposition states collapse when they interact with the environment, the connections between parallel selves might be disrupted by the complexity of biological neural networks. Maintaining quantum coherence across the billions of neurons in the human brain requires incredibly precise conditions that are nearly impossible to achieve naturally. However, advanced technologies might eventually allow us to enhance these quantum connections and recover memories from parallel lives. Brain-computer interfaces that can manipulate quantum states in neural tissue might enable controlled access to the experiences of alternate selves. Instead of being limited to a single stream of consciousness, you might learn to navigate between different threads of parallel experience. Imagine being able to remember not just your own life, but the lives of versions of yourself who made different choices at key decision points. You could experience the career you didn't pursue, the relationships you didn't develop, the places you never traveled to. Every path not taken would become accessible through quantum connections to parallel worlds where those paths were chosen instead. This multiversal memory access could transform human potential in ways we can barely imagine. Instead of being limited by the experiences of a single lifetime, each person could draw upon the accumulated wisdom of infinite parallel lives. Learning would accelerate dramatically when you can remember not just studying a subject once, but studying it thousands of different ways across thousands of different timelines. Problem solving would become vastly more powerful when you can access the solutions discovered by parallel versions of yourself who approached the same challenges from different angles. Creativity would explode when you can combine insights and inspirations from infinite alternative perspectives on the same fundamental questions. But perhaps the most profound impact would be on human empathy and understanding. If you could experience life from the perspectives of parallel selves who made different choices, who faced different challenges, who lived in different circumstances, your capacity for understanding others would expand enormously. The version of you that grew up in poverty would understand struggle differently than the version that grew up wealthy. The version that chose a different career would have insights unavailable to your current professional perspective. The versions that loved different people would understand relationships through completely different lenses. Access to these parallel perspectives might finally allow humans to transcend the limitations of single timeline experience and develop truly universal empathy. Instead of trying to imagine what life is like for others, you could literally remember living their lives in parallel realities where you made their choices. This multiversal consciousness expansion could be the key to solving humanity's greatest challenges. Climate change, poverty, conflict, disease. These problems persist, partly because we struggle to understand perspectives different from our own. If we could access the wisdom of parallel selves who lived through every conceivable variation of human experience, we might finally develop the insight needed to create truly harmonious civilizations. But such profound changes to human consciousness would also bring unprecedented risks and challenges. How would society function if everyone could access memories from infinite parallel lives? Would individual identity become meaningless when everyone can remember being everyone else? Would personal relationships survive when the boundaries between self and other become fluid and permeable? These questions push us to the very edge of what it means to be human in an infinite multiverse. As we continue to explore the implications of parallel worlds, we find ourselves confronting not just new physics, but entirely new possibilities for consciousness, identity, and the future of human civilization itself. The journey into parallel worlds has revealed that reality might be far stranger and more magnificent than we ever dared imagine, but it has also shown us that the greatest discoveries may not be about the external universe, but about the infinite depths of consciousness itself and our potential connection to every possible version of ourselves across the vast expanse of the multiverse. The quest to understand parallel worlds pushes us into territory where science meets philosophy, where mathematics encounters consciousness, and where the boundaries between possible and impossible begin to dissolve entirely. But as we venture deeper into this quantum labyrinth, we discover that the most profound implications aren't just about physics or cosmology. They're about the very nature of choice, responsibility, and what it means to live a meaningful life in a reality that might be infinitely larger than we ever imagined. Consider for a moment the weight of decision-making in a multiverse context. Every morning when you wake up, you face countless choices. Which shirt to wear, what to eat for breakfast, which route to take to work. In a single universe, these decisions seem trivial, barely worth conscious consideration. But if the many worlds interpretation is correct, each choice spawns entire realities populated by conscious beings living out the consequences of that decision. The version of you that chooses the blue shirt creates a timeline where everyone you encounter sees you wearing blue. The psychological effects of color on mood and perception ripple outward, subtly influencing every interaction throughout that day. A stranger might compliment your shirt, leading to a conversation that sparks a friendship that changes both of your lives. Or the color might subconsciously affect your confidence, making you more likely to speak up in a meeting, leading to a promotion that alters your entire career trajectory. Meanwhile, the parallel you that chose the red shirt experiences a completely different sequence of events. Different conversations, different moods, different opportunities. Both timelines are equally real, equally valid, equally filled with conscious beings whose lives unfold according to the patterns set in motion by your seemingly insignificant choice of clothing. This perspective transforms the mundane act of getting dressed into an exercise in cosmic responsibility. You're not just choosing what to wear. You're choosing what kinds of realities to create, what sorts of experiences to bring into existence across infinite parallel worlds. Every decision becomes an act of universe building on an incomprehensible scale. But this raises a paradox that strikes at the heart of human psychology. If every possible choice creates its own reality, does it matter which choice you make? If there's a universe where you choose every possible option, does free will retain any meaning? Why struggle with difficult decisions if all outcomes happen somewhere in the multiverse? Some philosophers argue that this apparent meaninglessness is actually liberating. If you don't have to worry about making the right choice because all choices happen somewhere, you're free to focus on making choices that align with your values and desires without the paralyzing fear of missing out on alternative possibilities. Others find this perspective deeply troubling. They argue that meaning comes from the significance of our choices, from the fact that selecting one path means sacrificing others. If all paths are taken somewhere in the multiverse, then choice becomes arbitrary and personal agency becomes an illusion. But perhaps both perspectives miss a deeper truth about consciousness and identity in a multiverse context. Your subjective experience of choice remains meaningful precisely because you can only experience one timeline. The other possibilities might exist in parallel realities, but they're not accessible to your current conscious experience. The choice you make determines which thread of the multiverse you'll continue to experience, even if other versions of you experience different threads. This creates a unique form of responsibility. You're not responsible for all possible outcomes across infinite realities. You're responsible for consciously choosing which reality you want to experience and which version of yourself you want to become. The parallel selves making different choices are separate individuals with their own moral agency, even if they share your history up to the point of branching. From this perspective, free will isn't diminished by the existence of parallel worlds. Instead, it becomes the mechanism by which consciousness navigates through the infinite branching structure of reality. Every choice is an act of self-determination, a decision about which possible future you want to inhabit. This navigation through possibility space might be more sophisticated than we currently understand. Perhaps consciousness doesn't randomly drift through parallel realities but actively influences which branches it experiences. Maybe the quantum processes in your brain don't just create random branching points, but actually steer your subjective experience toward realities that align with your deepest intentions and values. If this is true, then practices that enhance mental clarity and intentionality might literally influence which parallel world you experience. Meditation, visualization, and other consciousness-expanding techniques might not just change your subjective state, but actually guide you toward more favorable branches of the multiverse. This possibility has captured the imagination of researchers exploring the intersection of consciousness and quantum mechanics. Some propose that focused intention can influence quantum processes in ways that bias probability distributions toward desired outcomes. While such claims remain highly controversial within mainstream science, they point toward fascinating questions about the relationship between mind and reality in a quantum universe. The idea that consciousness might navigate between parallel worlds also offers new perspectives on phenomena that have puzzled psychologists and neuroscientists for decades. Why do some people seem unusually lucky, consistently experiencing positive coincidences and fortunate outcomes? Why do others appear to be trapped in cycles of misfortune that seem to transcend what pure chance would predict? In a multiverse context, these patterns might reflect differences in how effectively different individuals navigate through parallel realities. Those who experience consistent good fortune might unconsciously steer themselves toward branches where positive outcomes are more likely. Those plagued by bad luck might be stuck in unfortunate corners of the multiverse, unable to find their way to more favorable timelines. This doesn't mean that suffering is always the result of poor navigation, or that individuals are responsible for every misfortune they experience. The branching structure of reality includes timelines where terrible things happen through no fault of the people who experience them. But it does suggest that consciousness might have more influence over experienced reality than we currently understand. The implications extend beyond individual experience to collective human challenges. If groups of people can somehow coordinate their navigation through parallel worlds, they might be able to guide society toward branches where global problems like climate change, poverty, and conflict are more successfully addressed. This coordinated navigation might explain why social movements sometimes achieve seemingly impossible goals against overwhelming odds. When millions of people focus their intention on creating positive change, they might collectively steer society toward parallel timelines where that change is more likely to occur. The civil rights movement, the fall of the Berlin Wall, the rapid development of vaccines during the COVID pandemic. These historical moments involved overcoming obstacles that seemed insurmountable based on conventional analysis. Perhaps they represent instances where collective human consciousness successfully navigated toward more favorable branches of the multiverse. But coordinated navigation also carries risks. If consciousness can influence which realities we experience, then negative collective beliefs and expectations might steer us toward darker timelines. Fear, hatred, and despair might become self-fulfilling prophecies that guide society toward branches where those emotions are justified by external circumstances. This creates a profound responsibility for how we think about the future and what kinds of realities we imagine. If our expectations and beliefs influence which parallel worlds we experience, then cultivating hope, wisdom, and positive vision becomes not just personally beneficial, but cosmically important. The role of imagination in shaping experienced reality takes on new significance in this context. When you visualize a possible future, you might not just be engaging in mental fantasy. You might be exploring actual parallel timelines and potentially influencing which branches your consciousness will navigate toward. This possibility has led some researchers to investigate whether detailed visualization and mental rehearsal techniques can influence real-world outcomes through quantum mechanical processes. While the evidence remains preliminary and controversial, some studies suggest that focused mental imagery can produce measurable effects on physical systems, especially those involving quantum uncertainty. Athletes have long used visualization techniques to improve performance, imagining themselves executing perfect movements and achieving their goals. If consciousness can influence quantum processes, these mental rehearsals might literally be preparing the athlete to navigate toward parallel worlds where peak performance is more likely to occur. Similarly, the practice of setting intentions and visualizing desired outcomes might be more than psychological self-help. It might be a primitive form of technology for steering consciousness through the branching structure of parallel realities. As we develop better understanding of quantum consciousness, we might be able to refine these techniques into more powerful and reliable methods for reality navigation. But the power to influence which realities we experience also raises ethical questions about the nature of suffering and intervention. If some people are trapped in unfortunate branches of the multiverse, do others have an obligation to help them navigate toward better timelines? Can techniques for reality navigation be taught and shared, or are they inherently personal and subjective? These questions become even more complex when we consider the possibility that advanced civilizations in parallel worlds might already possess sophisticated technologies for navigating between realities. If such technologies exist, why haven't they been used to eliminate suffering across all branches of the multiverse? Perhaps there are fundamental limitations on interdimensional intervention that prevent even advanced civilizations from directly manipulating the experiences of parallel selves. Or maybe the diversity of experiences across infinite realities serves some deeper purpose that we don't yet understand, making it important to preserve both positive and negative timelines. Another possibility is that intervention is happening, but in ways so subtle that we don't recognize it as artificial. The apparently random quantum fluctuations that drive universe branching might be carefully orchestrated by advanced multiversal civilizations to guide the overall evolution of consciousness toward greater wisdom and compassion. From this perspective, the suffering and challenges we experience in our timeline might be necessary components of a vast educational program designed to develop the moral and intellectual capabilities needed for multiversal citizenship. Every difficult experience becomes a lesson, every triumph a graduation to higher levels of understanding. This educational interpretation of parallel worlds suggests that consciousness itself might be evolving across the multiverse, growing in sophistication and capability through the accumulation of experiences across infinite timelines. Each conscious being in every parallel reality contributes to this collective learning process. Your struggles and achievements in this timeline add to the vast library of experience that consciousness uses to understand itself and reality. The parallel versions of you living different lives contribute their own unique perspectives and insights. Together, all versions of all conscious beings across all realities participate in an inconceivably vast exploration of what it means to exist. This cosmic perspective on individual experience provides a framework for finding meaning even in suffering and failure. Every disappointment you face teaches lessons that become part of the multiversal wisdom. Every mistake you make in this timeline helps other versions of yourself in parallel realities avoid similar errors. The loneliness and isolation that sometimes characterize human existence might be illusions created by our limited perception. In reality, you are connected to infinite versions of yourself and others across the multiverse, all participating in the same grand exploration of consciousness and existence. But perhaps the most profound implication of parallel worlds is what they reveal about the nature of love and connection. If everyone you care about exists in infinite variations across parallel realities, then your relationships extend far beyond the single timeline you directly experience. The person you love in this reality is connected to infinite versions of themselves living different lives, making different choices, experiencing different joys and sorrows. Your love for them encompasses not just who they are in this timeline, but who they could be across all possible worlds. This multiversal perspective on love suggests that deep connections between conscious beings might transcend the boundaries of individual timelines. When you feel an inexplicable bond with someone you've just met, You might be recognizing quantum correlations with parallel selves who have known each other across multiple realities. The phenomenon of soulmates might reflect the existence of consciousness patterns that consistently find each other across different branches of the multiverse. Two people who feel destined to be together might indeed be following quantum threads that connect their parallel selves across infinite realities. But this also means that loss and separation in one timeline don't necessarily represent permanent endings. The person you've lost in this reality continues to exist in countless parallel worlds. While you can't directly access those other timelines, the quantum correlations between parallel selves might allow some form of continued connection that transcends the boundaries of individual realities. Grief becomes more complex in a multiverse context. You're not just mourning the loss of someone in your timeline, you're experiencing separation from infinite versions of that person who continue to exist but remain inaccessible to your direct experience. The pain of loss might reflect the quantum disconnection from parallel selves who are still together in other realities. Yet this same perspective offers hope for reunion beyond physical death. If consciousness persists across parallel worlds, then death in one timeline might simply be a transition to experiencing different branches where connection is possible again. The patterns that define individual identity and relationship might be preserved in the quantum structure of the multiverse, waiting to be accessed through means we don't yet understand. As we push deeper into these possibilities, we find ourselves at the edge of what current science can tell us about reality. The questions we're exploring push beyond established physics into realms where speculation and imagination become necessary tools for understanding. But perhaps that's appropriate. If parallel worlds exist, they represent possibilities so vast and strange that our current scientific methods might be inadequate for fully comprehending them. We might need new forms of investigation that combine rigorous empirical research with expanded consciousness and enhanced intuition. The journey into parallel worlds has revealed that reality might be infinitely larger and more mysterious than we ever imagined. But it has also shown us that consciousness itself might be the key to understanding and navigating this vast multiversal landscape. Every choice you make, every thought you think, every moment of awareness you experience might be part of a cosmic exploration that spans infinite realities and encompasses every possible form of existence. You are not just an isolated individual living a single life. You are consciousness itself, exploring its own infinite potential through every conceivable variation of experience. The implications of this perspective continue to unfold as we develop new technologies, conduct new experiments, and expand our understanding of quantum mechanics and consciousness. We stand at the threshold of discoveries that might revolutionize not just our scientific worldview, but our understanding of what it means to be alive in a universe that might be infinitely larger and stranger than we ever dared imagine. But even as we explore these cosmic possibilities, we return to the fundamental questions that started our journey. Do parallel worlds actually exist? Are there infinite versions of you living infinite variations of your life? And if so, what does that mean for how you choose to live in this reality, in this moment, with this particular thread of consciousness that you call yourself? The answers to these questions might reshape everything we think we know about existence, choice, and the nature of reality itself. As we continue to probe the quantum foundations of the universe, we may discover that the most profound truths aren't hidden in distant galaxies or exotic particles, but in the infinite branching structure of possibility that surrounds every moment of conscious experience. The cat in Schrödinger's box might not be alone in its quantum superposition. All of us might be quantum cats, living and dying, choosing and not choosing, across infinite parallel realities that remain forever tantalizingly beyond our direct perception, but intimately connected to every thought, every decision, and every moment of awareness we experience in this strange and wonderful quantum universe we call home. The search for evidence of parallel worlds has led scientists down some truly unexpected paths. While we can't directly observe alternate realities, researchers have discovered phenomena that seem to hint at their existence in ways that challenge our most basic assumptions about the nature of space, time, and consciousness itself. One of the most intriguing discoveries comes from studying the behavior of particles in quantum tunneling experiments. When particles pass through energy barriers that should be impossible to cross according to classical physics, they don't just mysteriously appear on the other side. Detailed measurements reveal something far stranger. The particles seem to carry information about paths they never actually traveled in our reality. Imagine rolling a ball toward a hill that's too high for the ball to climb over. Classically, the ball should bounce back, but in the quantum world, there's a small probability that the ball will appear on the other side of the hill, having somehow passed through solid matter. When precision, they find traces of interactions that scientists measure these tunneling particles with extremed only have occurred if the particle had taken routes through space that don't exist in our universe. Where do these impossible path signatures come from? The many worlds interpretation offers an elegant explanation. The particle doesn't just tunnel through the barrier in our reality. It explores every conceivable route in parallel universes, including paths that go around the barrier, over it, and through dimensions we can't perceive. The particle we observe carries quantum information from all these parallel journeys, creating interference patterns that reveal the shadows of alternate realities. These shadow interactions have been documented in laboratories around the world, but their implications extend far beyond particle physics. If fundamental particles can access information from parallel paths they never traveled in our universe, what does this mean for more complex systems? Could biological processes, chemical reactions, or even neural networks in the brain tap into similar multiversal resources? Recent experiments with photosynthesis have revealed optimization strategies that seem impossible according to single-universe physics. Plants convert sunlight to energy with an efficiency that approaches theoretical limits, using quantum processes that appear to explore multiple pathways simultaneously. The photosynthetic machinery doesn't just find the most efficient route for energy transfer, it somehow evaluates every possible route in parallel, selecting the optimal path with a precision that suggests access to computational resources beyond what should be available in a single reality. Birds navigating during migration display similar impossible optimization. They don't just follow magnetic field lines or use simple compass directions. Their navigation systems appear to process quantum information about magnetic field variations across vast geographic regions simultaneously, creating internal maps that account for possibilities they could never have directly experienced. The precision of avian navigation suggests access to parallel computations that evaluate countless alternative routes before selecting the optimal flight path. But perhaps the most compelling evidence comes from studies of human creativity and problem-solving. Neuroscientists have long been puzzled by moments of sudden insight, when solutions to complex problems appear fully formed in consciousness without any apparent logical progression. These eureka moments seem to involve accessing information that wasn't previously available to conscious awareness. Brain imaging studies reveal unusual patterns during creative breakthroughs. Instead of showing the gradual buildup of neural activity you'd expect from step-by-step reasoning, the scans show sudden, coordinated activation across multiple brain regions that weren't previously connected. It's as if the brain instantly accesses a complete solution that already exists somewhere else, then reverse engineers the logical steps needed to justify the insight. Mathematical proofs provide some of the clearest examples of this phenomenon. Mathematicians often describe the experience of discovering a proof as recognition rather than creation. They feel as if they're uncovering something that already exists, following a path that seems inevitable once revealed. The most elegant proofs feel almost supernatural in their beauty and simplicity, as if they were designed by an intelligence that understood mathematical truth from a perspective unavailable to any single human mind. This sense of mathematical discovery takes on new meaning in a multiverse context. If infinite realities exist, then every possible mathematical truth has already been discovered by mathematicians in parallel worlds. The quantum processes in our brains might occasionally access these parallel discoveries, allowing us to recognize proofs that have already been developed by alternate versions of ourselves or other mathematicians in different timelines. The collaborative nature of scientific progress supports this interpretation. Major discoveries often emerge simultaneously from multiple independent research groups, as if the ideas are somehow present in the collective unconscious waiting to be recognized. The timing of these parallel discoveries is too precise to result from coincidence, yet there's often no direct communication between the research teams involved. Consider the development of calculus by Newton and Leibniz, the simultaneous discovery of evolution by Darwin and Wallace, or the concurrent development of quantum mechanics by multiple physicists in the early 20th century. These parallel insights suggest that scientific knowledge might flow between parallel realities through quantum channels we don't yet understand. The implications extend beyond individual creativity to the collective evolution of human knowledge. If scientific discoveries can be influenced by parallel versions of ourselves who have already made similar breakthroughs, then the pace of human progress might be accelerated by quantum connections to more advanced civilizations in alternate timelines. This multiversal collaboration might explain why technological development often occurs in sudden spurts followed by periods of rapid refinement. The initial breakthrough represents the moment when quantum connections to parallel worlds become strong enough to transfer key insights. The subsequent refinement represents the process of adapting those insights to the specific conditions and constraints of our particular reality. But accessing knowledge from parallel worlds isn't just a matter of passive reception. It requires developing the cognitive and technological tools needed to recognize and interpret the quantum information flowing between realities. This creates a feedback loop where advances in our understanding of consciousness and quantum mechanics enable greater access to multiversal knowledge, which in turn accelerates our scientific progress. Some researchers are exploring whether meditation, sensory deprivation, and other consciousness-altering practices might enhance sensitivity to quantum information from parallel worlds. These techniques appear to quiet the neural noise that normally masks subtle quantum effects, potentially allowing access to insights that would otherwise remain undetectable. Advanced practitioners of meditation often report experiences of expanded awareness that seem to transcend the boundaries of individual consciousness. They describe moments of knowing without learning, understanding without thinking, and accessing wisdom that feels both foreign and intimately familiar. While these reports are typically interpreted in spiritual or psychological terms, they might actually represent enhanced sensitivity to quantum connections with parallel selves. The development of more sophisticated brain-computer interfaces might eventually allow technological enhancement of these natural abilities. By using external devices to amplify quantum coherence in neural networks, it might become possible to establish more reliable connections to parallel realities and access their accumulated knowledge on demand. But such technologies would also raise profound questions about the nature of individual achievement and collective knowledge. If our greatest discoveries and insights are influenced by parallel versions of ourselves, how much credit can we claim for our own accomplishments? Are we individual creators or participants in a vast, multiversal mind that spans infinite realities? These questions become even more complex when we consider the possibility that advanced civilizations in parallel worlds might be deliberately sharing knowledge with developing societies like our own. Perhaps the quantum information we occasionally access isn't just random leakage between realities, but carefully curated guidance from more experienced versions of humanity. This guided development might explain why certain crucial discoveries always seem to emerge just when they're needed most. The development of antibiotics during the rise of infectious diseases, the discovery of nuclear physics as energy demands increased, the emergence of computer technology as information processing became essential. These breakthroughs might represent interventions from parallel civilizations that have already navigated similar challenges. But if such guidance exists, it operates through channels so subtle that we rarely recognize it as external assistance. The insights feel like natural products of human creativity and intelligence, maintaining our sense of agency and accomplishment while secretly accelerating our development along beneficial trajectories. This hidden guidance might be necessary to preserve the authentic development of consciousness and civilization. If advanced parallel societies revealed themselves directly and offered explicit help, it might short-circuit the learning process that makes each civilization unique and valuable. The struggle to understand reality and develop wisdom might be essential components of conscious evolution that cannot be bypassed without losing something fundamental about the nature of awareness itself. From this perspective, the apparent isolation of human civilization isn't abandonment or cosmic indifference. It's a careful preservation of our developmental autonomy, allowing us to grow and learn at our own pace while receiving just enough subtle guidance to prevent catastrophic mistakes or evolutionary dead ends. The quantum connections between parallel worlds might serve as a safety net, ensuring that promising civilizations don't destroy themselves through ignorance or poor choices, while still allowing them the freedom to develop their own unique approaches to existence and knowledge. But as our understanding of quantum mechanics and consciousness advances, we might eventually develop the capability to recognize and interact more directly with these guidance systems. The transition from unconscious reception of multiversal knowledge to conscious participation in interdimensional collaboration could represent the next major phase in human evolution. This transition might require not just technological development but profound changes in how we understand consciousness, identity, and our relationship to reality itself. We might need to expand our sense of self to encompass not just our individual timeline, but our entire multiversal presence across infinite parallel lives. Such expansion of identity could fundamentally transform human psychology and social organization. Instead of seeing ourselves as isolated individuals competing for limited resources, we might begin to recognize ourselves as facets of a vast multiversal consciousness, exploring every possible variation of existence. This recognition could eliminate the fear and scarcity thinking that drives so many human conflicts. If every possible outcome occurs somewhere in the multiverse, then there's no need to fight over who gets to experience which possibilities. Every conscious being gets to explore every conceivable form of existence across infinite parallel lives. Competition might give way to collaboration as we realize that helping others develop their full potential ultimately enriches the entire multiversal community of consciousness. The success of any individual or civilization in any timeline contributes to the collective knowledge and wisdom available to all parallel selves across all realities. But this transformation also requires developing new frameworks for ethics and responsibility that can function across multiple realities. If our actions influence not just our local timeline, but parallel worlds through quantum connections, then we need moral systems that account for multiversal consequences. The choices we make might echo across infinite realities, creating patterns of behavior that influence the development of consciousness throughout the multiverse. Acts of kindness, wisdom, and creativity might strengthen positive trends across multiple timelines, while harmful actions might spread negative patterns that diminish the quality of existence in parallel worlds. This multiversal ethics creates both tremendous responsibility and tremendous opportunity. Every moment of conscious choice becomes an act of cosmic significance, contributing to the overall evolution of reality across infinite dimensions. But it also means that every effort to grow, learn, and create positive change has impacts far beyond what we can perceive in our single timeline. The implications continue to unfold as we develop new technologies for probing the quantum foundations of reality. Each experiment, each theoretical breakthrough, each moment of expanded awareness brings us closer to understanding our true place in the vast multiversal landscape of existence. We stand at the threshold of discoveries that might reveal not just the existence of parallel worlds, but our active participation in a cosmic community of consciousness that spans infinite realities and encompasses every possible form of existence. The journey into the quantum realm has shown us that we are not alone, not isolated, and not limited to the single thread of experience we call our individual lives. Instead, we might be part of something incomprehensibly vast and magnificent, a multiversal exploration of consciousness that includes every thought we've ever thought, every choice we've ever made, and every possibility we've ever imagined, all playing out simultaneously across infinite parallel realities that remain tantalizingly beyond our direct perception, but intimately connected to every moment of our existence. The cat in Schrödinger's box was never alone in its quantum superposition. We are all quantum cats, living infinite lives across infinite worlds, participating in an exploration of existence so vast and profound that even our wildest dreams of parallel realities might be just the beginning of understanding what it truly means to be conscious in an infinite multiverse. The search for concrete evidence of parallel worlds has pushed experimental physics into uncharted territory, where the line between science and what we once considered impossible continues to blur. But perhaps the most startling discoveries aren't coming from particle accelerators or quantum computers. They're emerging from careful analysis of phenomena we've observed for decades but never fully understood. Consider the puzzling behavior of biological systems at the quantum level. Living organisms operate with an efficiency that shouldn't be possible according to classical physics. Take the process of enzyme catalysis, where proteins speed up chemical reactions by factors of millions. These biological catalysts somehow find the optimal pathway for chemical transformation among countless possibilities, as if they're testing every conceivable route simultaneously. Recent studies of enzyme dynamics reveal quantum tunneling effects that allow reactions to proceed through pathways that should be energetically forbidden. But here's where it gets strange. The enzymes don't just use quantum tunneling randomly. They appear to coordinate these quantum processes in ways that suggest access to information about reaction pathways that don't exist in our reality. When researchers model enzyme behavior using only single-universe physics, their calculations fall short of explaining the observed efficiency. But when they include the possibility that enzymes might be accessing computational resources from parallel quantum states, the models perfectly match experimental results. It's as if these biological systems are borrowing processing power from alternate versions of themselves. This quantum enhancement isn't limited to simple chemical reactions. DNA replication, the process that copies genetic information with extraordinary accuracy, involves proofreading mechanisms that seem to evaluate error correction strategies faster than should be physically possible. The molecular machinery doesn't just catch mistakes, it appears to anticipate them, implementing corrections based on error patterns that haven't yet occurred in our timeline. The implications ripple outward into evolutionary biology itself. Natural selection operates through random mutations and environmental pressures, yet the fossil record shows periods of rapid evolutionary innovation that seem to transcend what gradual change should accomplish. New species appear with complex adaptations that would require millions of coordinated genetic changes, all happening within relatively brief geological timescales. But what if evolution isn't confined to single timelines? What if the quantum processes that drive genetic mutation allow life to explore evolutionary possibilities across parallel realities? Each organism might be testing countless genetic combinations simultaneously, with successful adaptations from parallel worlds influencing development in our reality through quantum resonance effects. This multiversal evolution could explain the apparent leaps in complexity that punctuate the history of life on Earth. The emergence of photosynthesis, multicellularity, consciousness itself. These breakthrough innovations might represent moments when quantum connections between parallel evolutionary experiments became strong enough to transfer successful adaptations across dimensional boundaries. The human brain presents perhaps the most compelling case for multiversal processing. Neuroscientists have long struggled to explain how 86 billion neurons, each making thousands of connections, can generate the unified experience of consciousness. The computational requirements for integrating all this neural activity should exceed the brain's physical capabilities by enormous margins. Yet consciousness emerges effortlessly, creating seamless experiences of perception, thought, and awareness that feel completely unified despite arising from massively parallel neural processing. Recent research suggests that quantum effects in microtubules within neurons might allow the brain to access computational resources from parallel versions of itself, effectively expanding its processing power beyond what should be possible in a single reality. This quantum consciousness hypothesis could explain some of the most mysterious aspects of human cognition. How do we instantly recognize faces among thousands we've seen? How do we navigate complex social situations requiring simultaneous processing of verbal, emotional, and contextual information? How do we generate creative solutions that seem to emerge from nowhere? Perhaps these cognitive abilities rely on quantum connections to parallel versions of our brains that have already processed similar information or faced comparable challenges. The feeling of familiarity when meeting someone new might reflect quantum resonance with parallel timelines where you've interacted with similar individuals. The sudden insight that solves a difficult problem might represent accessing a solution that parallel versions of your mind have already discovered. But the most intriguing evidence comes from studies of collective human behavior. Large groups of people sometimes coordinate their actions in ways that seem to transcend normal communication channels. Financial markets exhibit patterns of synchronization that can't be explained by available information. Social movements emerge simultaneously in disconnected regions without apparent coordination. Cultural innovations spread faster than traditional communication should allow. These collective phenomena might reflect quantum entanglement between human consciousness across multiple realities. When millions of people focus their attention on similar concerns, they might create quantum correlations that allow information and behavioral patterns to transfer between parallel timelines. The wisdom of crowds might literally involve accessing the collective intelligence of parallel societies. This multiversal coordination could explain why certain ideas seem to be in the air during particular historical periods. The Renaissance, the Enlightenment, the Scientific Revolution, these periods of rapid cultural and intellectual development might represent times when quantum connections between parallel civilizations became especially strong, allowing accelerated exchange of knowledge and innovation. But if humans can access information from parallel realities, why isn't this ability more reliable and controllable? The answer might lie in the fragile nature of quantum coherence in biological systems. The warm, noisy environment of living tissue quickly destroys the delicate quantum states needed for interdimensional communication. Only under special circumstances can these quantum effects persist long enough to transfer meaningful information. Meditation, altered states of consciousness, moments of deep concentration. These conditions might create the neural quiet necessary for quantum coherence to emerge. The heightened awareness reported by experienced meditators might reflect enhanced sensitivity to quantum information flowing between parallel versions of their consciousness. Some researchers are exploring whether technological assistance could amplify these natural abilities. Brain stimulation techniques that enhance neural synchronization might increase the probability of maintaining quantum coherence long enough for interdimensional communication. Advanced neurofeedback systems could help individuals learn to recognize and cultivate the mental states that facilitate access to parallel knowledge. But such technologies also raise profound ethical questions. If we can enhance human access to multiversal information, who gets to use these capabilities? How do we prevent the creation of cognitive inequalities between enhanced and unenhanced individuals? What happens to human agency and creativity if our greatest insights come from parallel versions of ourselves? Perhaps most importantly, what responsibilities do we bear toward the parallel realities we might be accessing? If our enhanced cognitive abilities allow us to tap into the accumulated knowledge of alternate civilizations, do we have obligations to those societies? Are we borrowing from parallel worlds without permission, or participating in a natural exchange that benefits all realities involved? These questions push us toward a new understanding of consciousness itself. Instead of viewing awareness as a property of individual brains, we might need to recognize consciousness as a fundamental feature of reality that extends across multiple dimensions. Each individual mind might be a focal point for a much larger multiversal intelligence that spans infinite parallel realities. This expanded view of consciousness could revolutionize our approach to mental health, education, and human development. Instead of treating the brain as an isolated information processor, we might develop therapies that help individuals strengthen their quantum connections to parallel selves. Depression might partly result from weak connections to happier parallel versions of oneself. Anxiety could stem from excessive quantum noise that prevents clear communication with alternate timelines. Educational systems might evolve to help students access knowledge that exists in parallel realities where they've already learned similar material. Instead of starting from scratch with each new subject, learners could tap into the accumulated understanding of parallel selves who have already mastered these concepts. The traditional model of sequential learning might give way to multiversal knowledge integration, but perhaps the most profound implications concern the nature of human potential itself. If consciousness can access resources from infinite parallel realities, then the limitations we perceive in our abilities might be artificial constraints rather than fundamental boundaries. The version of you reading these words might represent just one facet of a multiversal intelligence capable of achievements that seem impossible from a single timeline perspective. Every skill you've never developed, every language you've never learned, every creative expression you've never attempted might exist within reach through quantum connections to parallel versions of yourself. The key might lie in learning to recognize and cultivate these connections, developing the cognitive and technological tools needed to access the vast reservoir of experience and knowledge distributed across infinite realities. This potential for multiversal self-integration could transform what it means to be human. Instead of being limited by the experiences of a single lifetime, each individual might learn to draw upon the accumulated wisdom of infinite parallel lives. Personal growth could accelerate dramatically when you can access the lessons learned by versions of yourself who faced different challenges and made different choices. Relationships could deepen when partners recognize their connections to parallel versions who have loved each other across multiple timelines. Conflicts might resolve more easily when we understand that every perspective we encounter has been our own perspective in some parallel reality. Empathy becomes natural when you can literally remember experiencing life from every possible point of view. The transformation extends beyond individual experience to the collective evolution of human civilization. If humanity can learn to consciously coordinate across parallel realities, we might be able to solve global challenges by accessing solutions developed by more advanced versions of our species. Climate change, poverty, disease, conflict, these problems might have already been solved by parallel civilizations that developed along different trajectories. But accessing these solutions requires more than just technological capability. It demands a fundamental shift in how we understand our relationship to reality and to each other. We must learn to think beyond the boundaries of single timelines, recognizing ourselves as participants in a vast multiversal community of consciousness. This shift in perspective could eliminate many of the artificial divisions that separate humans from one another. Race, nationality, religion, ideology. These distinctions matter less when you recognize that every human being is connected to infinite versions of themselves who have belonged to every possible group and held every conceivable belief. The stranger you meet on the street is literally a parallel version of yourself from another timeline. Such recognition could create unprecedented levels of cooperation and compassion. Why harm someone who is fundamentally another version of yourself? Why hoard resources when infinite abundance exists across the multiverse? Why fear death when consciousness persists across infinite parallel realities? But this transformation also requires developing new frameworks for meaning and purpose that can function in a multiversal context. If every possible life is being lived by some version of yourself, what makes your particular timeline significant? How do you find motivation to grow and achieve when every possible outcome already exists somewhere? Perhaps the answer lies in recognizing that consciousness itself is engaged in an exploration of existence so vast that even infinite lives across infinite realities represent only the beginning of what's possible. Each moment of awareness, ever-expanding understanding of what it means to exist, each choice, each experience contributes to an as a conscious being in an infinite universe. Your individual timeline isn't just one random thread among infinite possibilities. It's your unique contribution to the cosmic exploration of consciousness, a perspective that has never existed before and will never be exactly replicated. The experiences you have, the insights you gain, the love you share become permanent parts of the multiversal library of existence. This cosmic perspective transforms every moment into an opportunity for discovery and growth. Every challenge becomes a chance to explore new facets of consciousness. Every relationship offers the possibility of deeper connection across dimensional boundaries. Every creative act adds something genuinely new to the infinite tapestry of existence. The journey into parallel worlds has revealed that reality might be far more magnificent and mysterious than we ever imagined, but it has also shown us that we are not passive observers of this cosmic drama. We are active participants, explorers of consciousness whose choices and experiences shape the very structure of reality across infinite dimensions. The cat in Schrödinger's box was never just a thought experiment about quantum mechanics. It was a glimpse into the true nature of existence itself, a reality where every possibility coexists, where consciousness spans infinite dimensions, and where each moment of awareness contributes to an exploration of existence so profound that our greatest dreams of parallel worlds might be just the first step toward understanding what it truly means to be alive in an infinite multiverse. As we continue to probe the quantum foundations of reality and develop new technologies for exploring consciousness itself, we stand at the threshold of discoveries that could transform not just our scientific understanding, but our entire experience of what it means to be human in a universe where every choice creates worlds, every thought spans dimensions, and every moment of consciousness contributes to an infinite exploration of existence that has no boundaries, no limits, and no end. The quest to understand parallel worlds has become the quest to understand consciousness itself, and the answers we discover might reveal that the two are ultimately inseparable aspects of a reality far stranger and more wonderful than we ever dared imagine. As we stand at the precipice of these revelations, a haunting question emerges from the quantum mist. If parallel worlds truly exist, if every decision spawns infinite realities, then what happens to the very concept of uniqueness? What happens to the precious notion that your life, your experiences, your struggles and triumphs mean something special in the grand tapestry of existence? This isn't just a philosophical puzzle. It strikes at the core of human psychology and our desperate need to matter. When you achieve something remarkable, when you overcome impossible odds, when you create something beautiful that moves others to tears, does that accomplishment lose its luster if infinite versions of you have achieved the same thing in parallel realities? The mathematics of infinity suggests something both terrifying and liberating. In an infinite multiverse, every possible achievement has been accomplished by some version of you. You've written every symphony, solved every equation, loved every person you've ever wondered about, but you've also failed in every conceivable way, made every possible mistake, hurt everyone you've ever cared about. This creates a paradox that philosophers call the meaninglessness problem. If everything that can happen does happen somewhere in the multiverse, then nothing you do seems to distinguish you from your infinite alternates. Your greatest triumph is simultaneously your most ordinary occurrence across the vast expanse of parallel realities. Yet perhaps this perspective misses something fundamental about the nature of experience itself. Your conscious awareness isn't distributed across infinite realities. It's focused here in this timeline, experiencing this particular sequence of moments. The version of you that discovers a cure for cancer in a parallel world doesn't diminish the significance of your struggle with illness in this reality. The alternate self who becomes a famous artist doesn't make your creative attempts any less meaningful. Each timeline carries its own weight of experience, its own texture of consciousness, its own irreplaceable contribution to the infinite symphony of existence. You are not competing with your parallel selves for significance. You are collaborating with them in an exploration of what it means to be conscious in ways that no single timeline could ever achieve alone. But this collaboration might be more literal than we realize. Recent theoretical work in quantum consciousness suggests that the boundaries between parallel selves might be more porous than previously thought. Under certain conditions, information and even aspects of experience might flow between nearby realities, creating a form of multiversal memory that transcends individual timelines. Imagine discovering that the skills you've struggled to develop weren't learned entirely from scratch. Instead, your brain might be accessing quantum echoes of parallel selves who mastered these abilities through different paths. The musician's fingers that seem to remember songs they've never played, the mathematician who intuitively grasps proofs they've never studied, the artist whose brush moves with confidence that exceeds their conscious experience. These moments of inexplicable competence might reflect temporary synchronization with parallel versions who have already traveled these learning paths. Your consciousness doesn't just exist in isolation, it participates in a vast network of alternate selves, occasionally sharing insights and abilities across dimensional boundaries. This quantum skill sharing could explain why certain individuals seem to possess talents that far exceed their apparent training or experience. Child prodigies who play complex music before they can properly hold their instruments. Young scientists who intuitively grasp concepts that took their teachers decades to understand. Artists who create masterpieces while barely out of childhood. Perhaps these exceptional individuals aren't freaks of nature or blessed with supernatural gifts. They might simply be more naturally attuned to the quantum connections that link them to parallel selves. Their unusual abilities could result from enhanced access to the accumulated experience of alternate versions who develop these skills through conventional means. But if consciousness can access abilities from parallel realities, it raises disturbing questions about personal identity and authentic achievement. When you accomplish something remarkable, are you drawing on your own effort and talent, or are you channeling capabilities developed by alternate selves? Where does your individual identity end and your multiversal self begin? These questions become even more complex when we consider the possibility that some parallel selves might be far more advanced than others. In infinite realities, there must be versions of humanity that have transcended our current limitations, developing capabilities that seem godlike from our perspective. These advanced parallel selves might possess knowledge about consciousness, reality, and existence that could revolutionize our understanding of everything. The quantum connections that allow skill sharing between nearby realities might also enable knowledge transfer from these advanced civilizations. The greatest scientific breakthroughs, artistic masterpieces, and philosophical insights in human history might have originated not from individual genius, but from quantum downloads of wisdom developed by more evolved versions of ourselves. This possibility transforms our understanding of human progress and potential. We might not be struggling alone to understand the universe and our place within it. We might be part of a vast multiversal intelligence that spans every level of development, from primitive consciousness barely emerging from biological evolution to cosmic awareness that transcends physical reality entirely. The most advanced versions of ourselves across the multiverse might be actively guiding our development, seeding insights and innovations through quantum channels that operate below the threshold of conscious awareness. What we experience as inspiration, creativity, and breakthrough understanding might actually be carefully orchestrated assistance from parallel selves who have already navigated these challenges. But why would advanced parallel civilizations invest effort in guiding less developed versions of themselves? The answer might lie in the interconnected nature of multiversal consciousness. If all realities are ultimately aspects of a single, vast intelligence exploring every possible form of existence, then the advancement of any part benefits the whole. Every breakthrough achieved by developing civilizations adds new perspectives and possibilities to the collective multiversal knowledge. The struggles and discoveries of less advanced societies contribute unique insights that even highly evolved civilizations value. Progress isn't a ladder where higher levels look down on lower ones. It's a vast exploration where every experience, no matter how primitive or advanced, offers irreplaceable contributions to understanding existence. This interconnected development model suggests that your current struggles and achievements matter not just to you, but to the entire multiversal community of consciousness. The challenges you face, the solutions you discover, the growth you experience become part of the infinite library of existence that all parallel selves can potentially access. Your depression teaches lessons about consciousness under stress that benefit versions of yourself who haven't faced similar challenges. Your moments of joy contribute understanding about happiness that enriches the experience of parallel selves who struggle to find fulfillment. Your creative expressions add new forms of beauty to the multiversal collection of artistic achievement. But this interconnected consciousness also implies responsibilities that extend far beyond your individual timeline. If your experiences influence parallel realities through quantum connections, then how you choose to live affects not just your local world, but the entire structure of multiversal existence. Acts of kindness might strengthen compassionate patterns across multiple realities. Moments of courage could inspire bravery in parallel selves facing their own fears. Creative breakthroughs might seed artistic innovations in countless alternate timelines. Even your private thoughts and emotional states could ripple across dimensional boundaries, influencing the quality of consciousness throughout the multiverse. This creates an ethical framework that transcends traditional morality. You're not just responsible for the consequences of your actions in your immediate reality. You're participating in the ongoing creation of consciousness itself across infinite dimensions. Every choice becomes an act of cosmic significance, contributing to the overall evolution of awareness throughout the multiverse. Yet this vast responsibility comes with equally vast support. You're not facing your challenges alone. Every difficulty you encounter has been successfully navigated by parallel versions of yourself. Every skill you need to develop has already been mastered by alternate selves. Every problem you face has been solved by other realities where different approaches were tried. The quantum connections that link parallel selves mean that you have access to infinite wisdom, infinite experience, infinite love and support from versions of yourself who have walked every conceivable path. The lonely struggle of individual existence transforms into participation in a vast community of consciousness that spans every possible reality. But accessing this multiversal support requires developing new capacities for awareness and connection. Most humans remain largely unconscious of their quantum links to parallel selves, experiencing only occasional glimpses of the vast network of consciousness they're embedded within. Learning to consciously navigate these connections could revolutionize human potential and experience. Meditation practices that enhance quantum coherence in the brain might strengthen connections to parallel realities. Consciousness-expanding techniques that quiet mental noise could make quantum information from alternate selves more accessible. Technologies that amplify subtle quantum effects in neural networks might eventually allow direct communication with parallel versions of consciousness. The journey into parallel worlds reveals a truth more profound than we ever imagined. Every choice you've made, every path you've taken, every moment of doubt or certainty exists simultaneously across infinite realities. You are not alone in your timeline. You are part of an incomprehensibly vast exploration of consciousness that spans every conceivable possibility. Whether parallel worlds exist as literal realities or remain theoretical constructs, the implications transform everything. Your decisions matter not because they determine a single future, but because they contribute to the infinite symphony of existence playing out across countless dimensions. Every struggle teaches lessons that echo through the multiverse. Every triumph adds beauty to the cosmic library of achievement. The cat in Schrödinger's box was never the real mystery. The mystery is you, existing in quantum superposition between infinite possibilities, conscious and aware in this particular thread of reality, while countless other versions live out every conceivable variation of your story. In a universe where every choice creates worlds, your life becomes both infinitely meaningful and beautifully ordinary, one note in an endless composition that has no beginning and no end.